Next I think.
Okay. So let's continue the next question. An insect is crawling upward. Bowl coefficient of friction between the bowl and the insect is 0.75. As the insect moves up till it feels it cannot go up from a certain height from the ground. We have to find out what is that height from the ground. So let's understand it with this idea. This is the bowl, let us say hemispherical bowl. The radius of the bowl is given as, let us say, r. So when the insect is crawling up, it will go till certain moment, it will not able to crawl up. The reason is very simple, that the friction is not providing that force needed to push it up. So at some position, let us say, making an angle theta, the frictional force, maximum frictional force, was able to balance mg sin theta. That is, the component of mg along the tangential direction. So this is mg along this direction. If suppose this is equals to theta, then this will be equals to mg cos theta. The normal action acting on the insect will be n, that is equals to mg cos theta. At some point you will get something like this, that is mg sin theta, which was acting downward, was balanced by the frictional force. At extreme case, the frictional force will become mu n, which is mu mg cos theta. So we can write down mg sin theta is equals to mu mg cos theta, which you can be easily understandable that tan theta equals to mu. Tan theta is equals to, tan theta will be equals to mu. Well, once you get the value of tan theta, which is given in the question as 0.75, that is equals to 3 by 4. So if tan theta equals to 3 by 4, then all of you can understand theta equals to 37. Now based on that, studying maximum height from the ground. So join this line. This is the height up to which it can crawl. So this height we have to find out. If this angle is theta, then that height h will be equals to r minus r cos theta. If this is supposed to say r cos theta, then total length is r, so h is equals to r minus r cos theta. So putting the value of cos theta is equals to 4 by 5 and r equals to 1 meter, you can get the maximum height it can reach. Correct? That is the solution of this question. So after this question, we will go to the next question.
Sir, button on the sir.
So the next question is, a point object is placed at 1 meter in front of a convex lens of focal length 0.5 meter. A plane mirror is placed 2 meter behind the lens. Find the distance of the image from the mirror and its nature of the image finally formed by this system. So in this particular case, we have to find out the final image position as well as the nature of the image because of a system of a convex lens and a plane mirror. So when you have to find out the position of the image, so let us draw the diagram first. The diagram is like this. This is the convex lens and the focal length of the convex lens f is given as 0.5 meter and focal length is 0.5 meter. The object is placed, a point object is placed at a distance of 1 meter. So this distance, this is the position of the object which is at a distance of 1 meter. So if the focal length is 0.5, this is 1 meter, all of you can understand, it is at 2f, so image will form at the same position, same distance from the object, so same distance from the lens. So if this is 1 meter, this is 1 meter. So basically it's a real image which is formed over here and the size of the image is also equal to the size of the object, okay? And magnification, you know that it should be negative because this is an opposite side of the lens. Now once this form the image here, let us say this is O and this become I, that is I1, that is image of the convex lens. Now I have got a plane mirror which is a distance of 2 meter from this convex lens. So it at a distance of 2 meter means you have to take the plane mirror somewhere here. Now the distance of the I1, that is the image of the convex lens which become object for the plane mirror, is at a distance of 1 meter. So obviously all of you can understand it will produce a virtual image somewhere here. And the ray which is getting reflected will appears to come from which position? So this is 1 meter, which appears to come from the same distance, which is 1 meter. So that is the image position I2. So in this entire diagram, what you can understand is that I1 is the image of convex lens, I2 is the image of the plane mirror, which become now object for this lens. And what should be the object distance for this lens? You can find out the object distance from the data given in the question. 1, 1, 1. So this become 3 meter. Now for this lens, the object distance is 3 meter, focal length is 0.5, incident rays are actually diverging rays, so represent a real object, correct? Which is actually a virtual image for the plane mirror. So now I will write for this lens 1 by V minus 1 by U is equals to 1 by F. Now for this particular situation, we have to get U is equals to minus 3, F is equals to 0.5. So I write 1 by V is equals to minus 1 by U is equals to, given in the question as 3 meter from the other side. So we write minus, because it is against the incident rays we are going, so we write minus 3 is equals to 1 by F, which is 1 by 2, so it will become 1 into 2. Now that will give you the value of V. 1 by V is equals to 2, this is plus, so we will get 2 minus 1 by 3, which is giving you, this is 3 into 2, 6 minus 1, that is equals to 5 by 3. So this is the position of the image which will be formed on the other side based on whatever the memory of the student, they have given this particular data. Based on that, I got this answer. Now this is the solution of some of the questions which you have found out, some of the questions which I have found out from the students. And I hope that questions are not in the difficult level. All our questions are basic questions. 1 or 2 questions are a little bit calculated. Otherwise, you will find out no difficulty in solving all this question. Hope you have done well. Thank you very much.